Bridgestone, the name synonymous with quality and performance, is proud to introduce the RFT, a state-of-the-art run-flat tire. This innovative tire has been designed to keep vehicles traveling safely and under control even after a puncture and air pressure loss. In fact, with the Bridgestone RFT, customers may not notice they've had a puncture. For this reason, a tire pressure monitoring system, or TPMS, must be used. Bridgestone has been a pioneer in developing, producing, and testing run-flat tires for over 20 years. Even with zero pressure, Bridgestone's self-supporting run-flat tires can easily support the weight of the vehicle and passengers. The key to Bridgestone's revolutionary RFT lies in its unique design. Compared to a standard tire, the RFT has a thicker, reinforced sidewall made of special heat-resistant rubber and a larger, stronger bead core to prevent the tire from rolling off the rim. The advantages of Bridgestone's run-flat tires are obvious. Now, the dangers and inconvenience of having to change a flat tire are becoming things of the past. The run-flat tire allows your customers to remain mobile until they can reach a professional, certified RFT location for service. It's important to note that a significant advantage to Bridgestone RFTs is that they can be mounted on standard rims, allowing any standard radial tire to be used as a temporary replacement. Each RFT has an individual pressure sensor for monitoring the tire's inflation pressure. In this vehicle, when the tire pressure drops to 26 psi, a warning light illuminates. Should the pressure continue to drop to 14 psi or lower, it will start blinking and an alarm will sound to alert the driver. Even in the case of a serious puncture, the Bridgestone RFT will continue to operate safely, taking the customer out of danger. Today, there are two major tire pressure monitoring systems available. Each system uses different pressure control units. Bridgestone's RFT can be used with both systems. The first system, sensor-based TPMS, uses individual sensors to measure the pressure inside each tire. A transmitter in the sensor transmits the amount of pressure in the tire to a receiver. The receiver then transmits this information to an onboard control unit, which warns the driver of the tire condition. The second type of system is an ABS-based TPMS. This system works on the principle that any loss of tire pressure reduces a wheel's circumference, causing the speed of the wheel to increase. This increase in wheel speed is then measured and compared with the other wheels in the ABS system. Once a pressure loss is recognized, the system instantly alerts the driver that the tire has suffered a loss in air pressure. One day all cars may be equipped with run-flat tires. Run-flat tires from Bridgestone, state-of-the-art technology. Stop the videotape. Go to your workbook and read the section on run-flat tire technology. Complete the appropriate review questions. Then restart the videotape. Run-flat tires provide a number of significant advantages. With run-flat tires, drivers are better able to maintain control of their vehicle and continue driving even after total air loss in one or more tires. In addition, the vehicle can keep traveling up to 50 miles at a maximum speed of 55 miles per hour, which should reduce the dangers and inconvenience of having to change a tire on the roadside. Clearly, run-flat tires offer great benefits. Demounting and mounting run-flat tires, however, requires special equipment, specific demounting and mounting procedures, and exceptional care. Currently, run-flat tires and tire pressure monitoring systems are found primarily on custom wheels, and these expensive automotive components require careful handling. Even though run-flat tires are durable, the failure to take proper precautions during demounting and mounting can lead to bead damage, and tires with damaged beads must be removed from service and destroyed. There are two types of tire pressure monitoring systems: ABS, and wheel-mounted sensors. In this video, we'll focus specifically on the tire pressure monitoring system that uses a combined sensor and valve mounted in the wheel. The workbook accompanying this video reviews information about mounting and demounting run-flat tires that use the sensor and valve combined system, as well as run-flat tires that use a separate sensor and valve, or band type. We'll be demounting and mounting a 275/40 R18 run-flat tire on an 18 by 9.5 inch Corvette wheel. For this demonstration, we'll demount and mount this tire from a wheel that's been removed from service and is used for training and practice purposes. To ensure that demounting and mounting procedures are performed properly, you must use the appropriate equipment that is specially outfitted with protective adapters, boots, and clamps. It's important to follow proper mounting and demounting procedures so that you don't damage the tire pressure monitoring system. In this video, we will cover how you use this equipment to avoid any such damage and associated costs. The mounting and demounting processes presented in this video may vary slightly according to the type of tire machine used. The process of demounting a run-flat tire begins with inspecting the wheel's surface, lug holes, and hub center for any nicks or scratches. Document any damage you find on the inspection form and let the sales associate know about it immediately before continuing. If the tire appears to be free of any damage or previous repairs, deflate the tire. Start by removing the cap and valve core from the stem. When removing the valve core from the stem, be alert. Does the valve stem have a hex ferrule? A valve stem with a hex ferrule looks different than a regular metal valve stem. If you spot a hex ferrule, then you know you have a sensor and valve combined type tire pressure monitoring system. The valve serves as an antenna that provides wireless transmission to the vehicle's information center. While the tire is deflating, remove the balance weights from both sides of the wheel. Depending on the type of weight, leaving the weight on the wheel may prevent the wheel from being evenly clamped on the tire changer. If the wheel is not level with the tabletop, the mount-demount head can scratch the wheel. If you leave weights on the wheel, they can snag and tear the bead area during the demounting process, which means you must remove the tire from service. Do not proceed until you have removed all the air from the tire. Never try to loosen the beads on a fully or partially inflated tire. This is an unsafe practice and can cause excessive movement and friction of the tire and wheel against the changer bumper pads. It can also increase wear on the pivot points of the loosening shoe. Before you continue, mark the vehicle wheel position on both the wheel and the tire. This is important because some sensors and valves are position sensitive, and you want to make sure you position the tire and wheel combination back on the vehicle properly. Carefully remove the hex ferrule. Gently push the sensor and valve assembly back into the tire cavity. This will avoid damaging the assembly during the demounting and mounting process. We're now ready to loosen the beads. Because the clamps on the tabletop may extend beyond the table, move them to their full inward position to avoid possible tire damage. Place the tire into the loosening shoe with the short or narrow side of the wheel facing out. Use extra care in positioning the bead loosener shoe on larger wheels and tires and on alloy wheels. Place the valve stem at the 2 o'clock position. Make sure the shoe rests next to, but not directly on the wheel and not on the tire sidewall. To avoid any damage to the wheel, the bead loosener shoe must be equipped with a boot protector. Press the bead loosener pedal to actuate the shoe and loosen the bead. You may find it necessary to loosen the bead in multiple locations around the tire. Now, turn the wheel around and loosen the bead on the other side. Once again, place the valve hole at the 2 o'clock position. It will be easier to clamp the wheel to the tabletop if the lower bead is loosened last. After you've loosened the lower beads, rotate the tabletop until the clamps are in the 12, 3, 6, and 9 o'clock positions. For custom wheels, the clamps must be outfitted with replaceable plastic socks that protect the wheel when clamping from the outside. Note that these plastic socks do not provide wheel protection when clamping from the inside, which is how you clamp steel wheels. Release the clamp control pedal to the up position to move the clamps outward. Next, move the clamp pedal halfway down and pre-position the clamps a little wider than the size of the wheel. Place the tire and wheel on the tabletop with the mounting side up. The mounting side of the tire is the short or narrow side of the drop center. Use the robotic arm to press down on the wheel to assure that the clamps will fit into the wheel flange. Move the clamps inward until they securely lock to the outer edge of the wheel. To correctly position the mount-demount head, use the robotic arm to depress the tire sidewall. To release the slide on the mount-demount head, pull the locking handle forward. Push down on the top of the slide to move the mount-demount head into contact with the wheel edge, and push the locking handle back to lock the slide in place. As the slide is locked, the mount-demount head moves up to approximately 1/8 inch from the edge of the wheel. You may also need to move it outboard a little more. Check the positioning of the mount-demount head. The bottom of the mount-demount head must clear the top of the wheel edge by 1/16 to 1/8 of an inch. The inside surface of the mount-demount head must clear the wheel edge by 1/16 to 1/8 of an inch. This clearance is maintained as long as the locking handle and the adjustment knob remain unchanged. Move the robotic arm out of the way. Because run-flat tires have a very stiff sidewall, you will want to use the bead roller tool to help push the tire sidewall down so you can lubricate the entire upper bead area. Lubrication is one of the main ways to protect the tire and wheel from damage, so liberally lubricate the entire circumference of the upper bead and the wheel itself. Just rotate the wheel while holding the lubricator in place. Remove the bead roller tool. Note that the valve stem hole is positioned near the mount-demount head. If the sensor could not be removed and was positioned in another location, it could be damaged when the bead slips down into the drop center. Use the robotic arm to push down the sidewall near the mount-demount head to begin removing the top bead. Lubricate and insert the smooth curved end of the bead lifting tool over the forward end of the mount-demount head and below the top bead of the tire. This bead lifting tool must always be covered with a plastic sheath to protect the tire and wheel. Reposition the robotic arm to the opposite side of the mount-demount head and press down on the tire bead to allow the bead to move into the wheel's drop center. This makes it easier to lift the upper bead up and over the mount-demount head.